two completely miscible liquids. Solution A, for example, has its own vapor pressure. Okay, and solution B has its own vapor pressure. When solution A and solution B are added to form a mixture, both liquids evaporate and contribute to the vapor pressure. As we know, solution can be divided into ideal solution and non-ideal solution. For the ideal solution, it obeys Raoults law. For example, the mixture of non-polar liquids, for example, toluene and benzene, and can also be uh, both polar liquids, for example, ethanol and methanol. Both liquids are volatile and the intermolecular attraction between molecules are same as in pure liquids. For the polar solute, it will dissolve in polar solvent. This is following the rules of thumb, like dissolve like. When the polar solute dissolves in polar solvent, it will form polar bonds or hydrogen bonds. Most nonpolar molecules are water insoluble, which is hydrophobic at room temperature. For example, we have hydrocarbon such as methane, ethane, or propane, and oil. Let's see the structure of methane. Methane is CH4. The bond in methane are arranged symmetrically, so there is no overall dipole. Furthermore, there will be no difference in electronegativity between carbon and hydrogen, so they will not have dipole. Now, let's have a look on the graph of pressure versus composition of benzene-toluene mixture. Benzene and toluene is a non-polar solvent. So this is a volatile system. Recall that with only two components, the mole fraction of benzene plus mole fraction of toluene is equals to 1. For benzene, when mole fraction of benzene is equals to 1, the partial pressure of benzene is equals to the vapor pressure of pure benzene, which is 384 torr. And when mole fraction of benzene is equals to 0, the partial pressure of benzene is equals to 0. For toluene, when mole fraction of toluene is equals to 1, the partial pressure of toluene is equals to the vapor pressure of pure toluene, which is 133 torr. And when the mole fraction of toluene is equals to 0, the partial pressure of toluene is equals to 0. So this is partial pressure of toluene. Benzene and toluenes are non-polar solvents. The attractive forces between molecules are weak and it is easily vaporized. The strength of the intermolecular attraction between benzene and benzene molecules are same with toluene and toluene molecule, and also between benzene and toluene molecule. Benzene are more volatile compared to toluene due to high vapor pressure. When two liquids are mixed in closed container, both components evaporate and produce pressure above the solution. According to Raoults law, the partial pressure of gas is directly proportional to mole fraction of liquid composition of an ideal solution. According to Dalton's law, it states that total pressure of solution is sum of partial pressure of gas in mixture. We can have total pressure P total is equals to partial pressure of benzene plus partial pressure of toluene. We know that partial pressure of benzene is equals to mole fraction of benzene times the vapor pressure of pure benzene. So we can substitute this equation into this equation in order to get the second equation. Dalton's law also states that partial pressure of gas is the product of mole fraction of gas and total pressure. So we can have partial pressure of benzene is equals to mole fraction of benzene times total pressure. Same goes to partial pressure of toluene. Gas or vapor composition of liquid in solution symbolized as Y is equals to Y benzene is equals to partial pressure of benzene over total pressure. Same goes to gas composition of toluene. Let's have a look on one example here. From the question, we know that the vapor pressure of heptane and octane is 92 millimeter of mercury and 31.0 millimeter of mercury respectively. And the mixture of heptane and octane will form an ideal solution. So the keywords here, ideal solution, meaning that it's follow Raoults law. A mixture of heptane octane containing 35% heptane is placed in closed vessel. So question A asks which component is more volatile. So we know that from the vapor pressure of heptane and octane, heptane are more volatile because of vapor pressure of heptane is higher compared to octane. Question B asks calculate the total pressure of the vapor formed above the solution. So question asks for P total. So we need to find mole fraction of heptane and mole fraction of octane. So mole fraction of heptane is equals to 0.35. How you know 0.35? It is 35% of heptane from the question. So 35 over 100, you will get 0.35. And we know that the mole fraction of A plus mole fraction of B is equals to 1. So we can find the mole fraction of octane. So it is 1 minus 0.35. So it is 0.65. We substitute all the value into this equation. We will get the final answer. The total pressure is equals to 52.35 millimeter of mercury. Question C asks calculate the vapor composition of octane in equilibrium with the solution. So using the formula, we substitute the value and we know now the pressure total is equals to 52.35 millimeter of mercury. So the final answer we will get 38.5%.